Hello, everybody. It's Mr. Collins. It seems like we were just here working a review to prep for a test, and look at that, we're back again. So this test is all going to be about working on the coordinate grid to do something, and really it's divided into four big parts. We have some circle stuff that we just finished in class. We have like the algebraic methods, like how do you find distance or how do you find slope. We'll have some calculations using distance, namely area and perimeter, and of course everyone's favorite, proofs. So just like all of the videos that I've produced, I'm going to do this in parts and try to break it up into nice digestible bits. And so let's jump right into part one, circle equations. Now again, the ideal way to work this review is not a page at a time, even though I am going over this a page at a time. Ideally, you're kind of doing just like 3 or 4 problems off of every page, going through the entire review. That way you have you space out your practice and have plenty extra as we draw near to test day, which is going to be Monday. So it's going to be just about a half a week away because today is Tuesday that I'm making this. And so we have to write some circle equations first. So we should probably remind ourselves what the circle equation general form is. That's the one that had like the H's and K's, or if you're with Mr. Hancock, you might have had like A's and B's. Either way, I have x minus h squared, y minus k squared is equal to r squared. And just like any other formula, we're just kind of matching up the pieces, okay? Now, we probably want to establish right away that the center we're looking for is going to be hk, and then the radius that we're looking for is going to be r. Okay? Now this is really just equation reading, but the thing we have to note, and the thing I want to remind you of the entire time, is that the formula itself has a subtraction problem in it. To find that difference, you're always going to subtract the x from the h and the y from the k, the xy from the center hk. And so if we see a minus sign and we see a plus sign, that's going to affect our center. Okay? For us, since we have a minus h and we have minus 16, that means the h is just going to be 16. Here we have a minus k and a minus 6, and so the center is just going to be 6. Okay? Also recall that the r squared value is equal to 1, so r squared is equal to 1, and so if I square root both sides, the r is just going to be 1. Okay? So for the first question, the center hk is 16 comma 6, and the radius is just going to be 1. Okay? So I'm going to start with the equation again. You're gonna find that that's my preferred method, is to write this equation over and over again. You may not need to, but that's just going to be my thing. All right, so we have the center, which is hk. And again, here we see the h is now a plus 5. Well, we have a subtraction problem from the formula, and it changes to a positive number, and so that means our h value has to be negative 5. Our k value does the same thing, and so we're looking at negative 7. And again, your teacher might have presented this in a different way. They might have you kind of just think about the rule that you reverse the signs from the formula to the center. But the reason that happens is because you have a negative and then a negative 5, making your positive 5, a negative from the formula, a negative from the number, producing that positive 7. Okay, so we're talking about the radius. Okay, well, r squared is equal to 36. So to solve r, we're going to square root both sides. So r is going to equal 6. Okay, remember the number you see that the equation is equal to is always a squared number. It's not just the radius, it's the squared radius. All right, so now that we have kind of a rhythm, okay, so our center hk, well, here we have a negative h, here we have a negative 1, and so we don't have that double signage, so our x value is going to be 1. Here we have a negative k that switches to a positive k. The only way to do that is to introduce a second negative, and so 3 has to be negative. Okay, we have the r value to be 4, so r squared is equal to 4, so 1 square rooted, r is going to equal 2. All right, we should probably box up some of these answers so it's a little bit easier to differentiate. Okay, and the rest of the problems are going to go the same way. So we're going to start with the equation. That's always my advice. X minus h squared, y minus k squared is equal to r squared. Okay, so we have negative h, negative 2, so no extra signage, and so h is just 2. Negative k changed to a positive 1, so we have one negative from the minus k. We have to introduce a second negative with a number, and so we have negative 1. Okay, r squared is equal to 16, and so r is equal to 4. Okay, so a natural question to ask at some point is, do I have to show all the work that you're showing, Mr. Collins? Well, no, you don't. I'm just showing you like what I typically do in order to get to the answer. Even after several thousand years of me solving math as a math student, I still like to show all my work. Okay, so the center HK, so we have negative h stays negative, so it's just going to be a 1. Negative k changed to a positive 4, so we have to carry an extra negative on the number. R squared is equal to 9. Okay, so r is equal to 3. Okay, so here we have kind of a weird one, right? Because we have x squared, there's no like plus or minus number, but that's actually a falsehood. There is a plus or minus number, we just don't have to write it. And the only number we don't have to write a plus or minus for would be 0. And so the h would be 0 in this case. Here we have a negative k staying negative 3. So k just has to, be 3. Okay, doesn't look like the radius is going to be a nice number because r squared is equal to 14. So when we square root to get r by itself, we have square root of 14, which is actually an okay number. You can leave it as a square root number, but your test may have it as a decimal. So let's put both down. Let's convert square root of 14, to a decimal. So square root of 14 is fine, but also 3.742, properly rounded off to 3 places. All right, here's another one where they're trying to throw us. Okay, there is no plus or minus on the x or the y, and so then my center, HK, the x value would be 0 and the y value is also 0. Okay, so that should be r squared. Okay, so r squared is equal to 36, and so r is equal to 6. And of course we just square rooted to get rid of the square, ergo the radius is 6. All right, plugging along here. Hopefully these are getting at this point a little bit routine, right? So like by this problem in the set, you should be hopefully feeling pretty good about locating the center and radius. Okay, so it stays negative, so we just need a 3. Stays negative again. It becomes a 4. Okay, for the radius, r squared is equal to 25, so once square rooted, r is equal to 5. So they're both negative, so that means the x coordinate is just going to be a positive 5. Here I change from a negative to a positive, so I have to introduce a second negative sign, because one negative from the formula, one negative from the number makes a positive number, in this case 4. All right, that should be, keep writing that radius. So the radius squared should be 41. So 1 square rooted. We can possibly leave the square root of 41, but since we don't know what the test is going to have us do, we also want to convert it to 6.403.
Okay, and there is no best form. Like, I know that question's gonna pop up in your head, like how should I leave it? Should I leave it as a decimal? Should I leave it as a fraction? Honestly, it doesn't matter which one you do, whichever, as long as you can convert back and forth between the square root number and the decimal number. All right, so the center, HK. Okay, well, H goes from negative to positive, so we have to introduce a second negative on the number. Two negatives make a positive. Here we have a K, here we have nothing, so that's going to be that 0. And then the radius is going to be 2, because r squared is equal to 4, and so r has to be 2. Of course, it's a negative 2 also, but radii can't be negative because it's a distance, and so we just ignore that and keep our positive value. Okay, that's going to be into part 1. In part 2, we're going to be writing equations based on information, but you're going to see the same kind of rhythm because if I can look at an equation and pull the center and radius, certainly if I'm told the center and radius or something like that, I can write the equation, but that's going to be in part 2. See you guys in